Hello, calculus students and serious seekers of truth. If you're not in a calculus class and you're watching this video still, you must be seriously seeking truth, at least mathematical truth. So we've done this part, we've done this, where we found the exact area. Now we're going to extend this idea to any other function. Okay? And we'll use what we've done so far as kind of a template or a jumping off point. So if we're in the very general case, we're asked to find this function, then what we're going to need to do is just kind of repeat what we did before. So let's just say f of x is some gnarly thing like this. This point right here is A. This far left point here is A, and this far right point here is B. Okay. So just like we did before, we're going to dice this up into a bunch of subintervals. So we're going to break this up into n subintervals. Okay. And x sub 0 is going to be the same thing as A. X sub 1 is going to be just to the right of that. X sub 2, dot, dot, dot. The second to last one is going to be x sub n minus 1. And then the very last one is going to be x sub n. Okay. So we're going to break this up into a bunch of little subintervals. And so we have n rectangles. Okay. Each of them with base. The base of each of these rectangles is x sub I minus x sub I minus 1. For example, the base of the first rectangle is x1 minus x0. The base of the second rectangle is x2 minus x1. Okay. And then the height of the rectangles is going to be f of c sub I. I forgot to mark that as the function f of x, is f of c sub I. And we're going to find c sub I. And this is the beautiful thing. So the way we choose c sub I is c sub I is the point where some other function, call it big F of x, average rate of change equals its instant rate of change. And another way of saying that is big F prime of c sub I is equal to f of c sub I, I'm sorry, not c sub I, c sub xi, f of x sub I, let me say that again, f of x sub I minus f of x sub I minus 1, all of it divided by x sub I minus x sub I minus 1. Okay, so C is some point in here. This would be C1, and I'm arbitrarily making these marks C2, C3, C4, all the way at somewhere in between here would be C sub n. Okay, and the way that we choose C sub n, or these C's, is they're the point where some other function's average rate of change equals its instant rate of change. Okay. Now, the key to all of this is how do we choose big F? Well, we could choose any function we want, but we want to choose big F such that f prime is equal to, big F prime is equal to little f prime. Remember, little f is the function whose area we're seeking. Big F is any other function we want, but the way that we want to choose it is where f, the derivative of big F, is equal to little f. In other words, big F is the antiderivative of little f. Okay. That's what we really want to do. And the reason we want to do that is that we can say now that the integral from a to b of f of x dx, remember, is equal to the limit as delta x approaches 0, where delta x is the size of the base of each rectangle, of the summation of f of c sub I times xi minus x sub I minus 1 from I equals 1 to n. Okay. But if we choose this well, then f of c sub I is equal to big F prime of c sub I, which is equal to this slope calculation, essentially. So this is equal to the limit of delta x approaching 0 of, and remember we can replace this with that. So we can replace it with f Now I forgot the summation symbol here. Okay. Whoops, running off the screen there. So we can replace this f of c sub I with this expression, because this expression is equal to the derivative of some point c sub I. But we chose, the key here is we choose big F so that big F is the antiderivative of F. So this expression here, so we can just say that, instead of saying f prime of c sub I, we can just say f of c sub I. So f of c sub I can be replaced with this slope calculation. And the nice thing is that this goes away and that goes away, and this is equal to the limit as delta x approaches 0. But if we write this out, this is f of x1 minus f of x0. Remember, that's our first term, plus our second term is f of x2 minus f of x1 plus f of x3 minus f of x2 plus ... I'll write out two of the last terms here. It's going to be f of x n minus f of x sub n minus f of x sub... Sorry, this should be f of x n minus 1. I'm going to write this all better. Minus f of... No, this would be f of x n minus f of x n minus 1. It's getting late in the day and I'm starting to mix things up. Okay, and from what we've seen before, we have a negative f of x1, positive f of x1, that goes away, positive f of x2, negative f of x2, that goes away. And in fact, all of these terms are going to go away. The only terms that are going to remain is this one and this one. Okay. So, and the limit, once you cancel all this term, doesn't even matter. So this is f of xn minus f of x0. But wait a minute. X of 0 is just a, and x sub n is just b. So we can rewrite this as f of b minus f of a. So I will write it this way. The definite integral of f of x dx from a to b is equal to big F of b minus big F of a, with one super important caveat. Big F is the antiderivative of little f. Okay. So now, as a little teaser and a quick example here, What is the integral from, oh, I don't know, 2 to 7 of x squared dx? Well, we know that we take the antiderivative of this function, which is 1/3 x cubed, okay, of b, which is 7, minus the antiderivative, 1/3 x cubed of a, which is 2. So this comes out to being 1/3 times 343 minus 1/3 times 8, which is 1/3 times 343 minus 8, which is 335 over 3. Okay, and you can compare this process to the solution that we did a few days ago. Don't be too mad at me for making you do all the extra work. You got to do it anyways, have some understanding and some appreciation. But this beautiful theorem here allows us to find these definite integrals by hand relatively quickly with an exact answer. Okay. There are some caveats to this, which we will talk about later, but for now, you can understand, you can hopefully use this idea to find the area underneath the curve. Thank you for watching. Thank you for following me. If this is, you're faithfully watching all these videos. As always, ask for help and clarifications, and especially on something this difficult. Have a wonderful day.